Good afternoon, everyone. Myself, Suresh, lecturer in mechanical engineering from Government Polytechnic, Chegunta. I'm going to deal with a subject called Advanced Workshop Technology. And today's topic is from Foundry. So, by completing of this class, we will be able to know about importance of casting, advantages of casting, and the disadvantages of casting, and also the hand molding tools used in Foundry. Okay, so before that, so we are able to know about the manufacturing, some of the manufacturing processes. Okay, so actually, what is the definition of the manufacturing process of manufacturing? So now we can see the definition of manufacturing. So manufacturing is the process of transferring the raw material into finished products. So here, so we are transforming the raw material into a finished product. So that process is called the manufacturing process. Okay. So here we can see some of the types of manufacturing processes. So among them is first one metal cutting or machining. Second, metal forming. Third, casting. The fourth one, powder metallurgy. Okay, so among them, first one we will see here. First one is machining. So, actually, what is a machining? So, machining is a process of removing excess material from the workpiece to make into a finished products. So, that is comes under the machining. So, by using some machines, they are performing different operations. Okay, so we are performing different operations by removing the excess material from the given workpiece so that so it will be make them into a finished products. For example, shafts, bolts, nuts, etc. So all these are the manufacturing machining. All these are performed on these machines. So this process is known as a machining. And the second one is metal forming. So actually, what is a metal forming? In metal forming, the material is shaped by a plastic deformation with the aid of an external pressure and heat. So in this metal forming process, so we are applying an external pressure and heat so that the metal will be deformed into some other shape. For example, hot working and cold working. Next, third one is metal casting. So actually, what is a metal casting? In metal casting, the material is shaped from liquid state to a required object by pouring a cavity called mold. So in metal casting, so what we are doing? So in this casting, the liquid state of material will be poured into a cavity so that so we'll get a mold. Example, a foundry. So next fourth one is a powder metallurgy. So actually, what is a powder metallurgy and what and how we are performing these powder metallurgical processes? So it is a process of making components from metal powders by pressing and sintering. So by sintering and pressing, so we are make them into a final component from the metal powders. This process is called powder metallurgy. So for examples, mass production of highly precision objects. This is comes under the powder metallurgy. So next thing is a foundry. So actually, what is a foundry? So here we can see some of the products which is produced from the foundry. So here first figure is a cylindrical block, and the second one is a wall. So these two products are prepared in the foundry. Okay. So actually, what is foundry? It is a process of making products from a molten metal is called a foundry. So what are the product? Whatever the products we are making from the from the molten metal, that those products that is comes under the process is called the foundry. The products obtained are called casting. So here we have cylindrical block and a wall. So these two are the castings prepared from the foundry section. So some of the examples like flywheel walls, gears, engine, cylinder blocks, etc. Okay. So steps in making a casting. How we are preparing a casting in foundry. So here some of these. So here there are some steps to prepare a casting. Okay, first one is pattern making. Second, mold and pour making. Third, melting and pouring. Fourth, fettling. Fifth, inspection. Okay, so first one is the pattern making. Okay, so now we are going to discuss about the what is a molten metal. So here we can see some of the metals are break them into a molten state. Okay, heat by applying some high temperature to the metals so that it becomes a liquid state or plastic state. Right. So cast iron, aluminum are melted in various furnaces to get them in liquid state. So here in this figure, we are melting the cast iron as well as the aluminum. Okay. So in various furnaces to get them into a liquid state. Okay. So we can see here. See, he is preparing in these two figures. Okay. So what are those figures? Those are the molds. So actually, what is a mold? So it is a hollow cavity of casting. Mold is a hollow cavity of casting. So it is made of molding sand. So molding sand is natural sand or synthetic sand. These are the generally we are using synthetic sands here. Okay, so in some cases we are using the natural sand. Okay, so these two sands are used as a molding sands. So pattern is kept in the molding sand to prepare mold. So how we are preparing the mold? So before going to prepare a mold, just take out the pattern and kept in the molding sand to prepare a mold. Next, actually, what is a pattern? A model or a model of required casting. So, pattern is nothing but it is a replica or a model. Okay, a model of a required casting. So, it is made of light material like wood, plastic, etc. So, so mainly we are using wood and plastic are the light materials to prepare a pattern. So pattern is used to make mold. Okay. Next, what are the advantages of foundry? You can see here. So this is the cheapest manufacturing processes, and this is a oldest manufacturing processes. Next, it is very fast. Okay. So intricate shapes can be produced. So what are the components? It's very difficult by some other machines. So those components can be prepared by using foundry. So complicated shapes can be produced or intricate shapes can be produced. No wastage of material. So here we are using the molten metal. So we are not wasting any molten metal and also the molding sand. So here also we are not wasting any molding sand. Okay. there is no wastage of material in foundry. Sorry. Right. There is no wastage of raw material in the foundry. Next, it is suitable for mass production. Foundry is suitable for mass production. Okay. And the limitations you can see here. The limitations of the foundry. So only suitable for raw materials or only suitable for materials with castability such as cast iron, aluminum and its alloys, gold. Okay, so these are the suitable materials. Yes. Okay, so who needs furnace to produce molten metal? Definitely, if you want to, definitely in this foundry, definitely the components or the material which is going to be molten. So that material to be first make them into a molten metal. It's in the furnaces. So next, usually castings are brittle and not too tough. Okay, so usually castings are brittle and not too tough. So next we can see here. So hand molding tools is the another topic from the foundry. So here we can see. So there are number of hand molding tools we are using in foundry. Okay. So among them, now we are going to discuss. I think so. We discuss all the molding tools now. Okay. So among them, first one is molding flask. So here we can see here. So this is a diagram of a molding flask. So this molding flask is used for small castings. So here we can, in this figure, we can observe there are two boxes here or two flasks here. So cope and drag. Okay. So with the help of a lock pin, so we are joining these two edges of this cope and drag boxes. Okay. So it is used for small castings, and these are made of either metal frame or by wooden. Next, so it is made them into two parts. So that is cope and drag. Next, the second one is molding boxes. So this is also one of the hand molding tool used in foundry. So here we can see. So this is a diagram of a molding boxes. So here we have drag and cope. Okay. Next. So this molding box is used for last castings. Okay. This is used for large castings. So it is made of wooden frame. So next one is molding board. So already we discussed about the molding boxes and molding frames. Now we are going to discuss about the molding board. So this is a diagram of a molding board. So we are using in foundry. Okay. Next. So this molding board is a smooth wooden board. So pattern is placed on this board. So molding box is also placed on it. So before going to place the molding box, just we have to check the whether the board is smooth or not. Then place the pattern in the middle of the molding board. Then after place the molding box on the top of the pattern. So the pattern should be in the middle of the molding board. Just we have to check the parts. So next, molding sand is poured and rammed to make compact. So after placing a pattern and a molding pattern within the molding box. So then pour the molding sand and rammed to make harder or compact. So next and the tool is shovel. So here we see the diagram of a shovel. Okay. The shovel is used for mixing and tempering molding sands. So this shovel is used for mixing and tempering molding sand. And this shovel is used for loading the sand into flasks or boxes. So this shovel is used for loading the sand into the flasks or into the molding boxes. Next one is a riddle. This is a diagram of a riddle. So we see here. So a riddle is a sieve of wire mesh fitted into a lead frame. So this riddle is used for screening molding sand. So in Foundry, so we have to use the screen and molding sand only. So that's why we are using the riddle for screening the molding sand. Next one is the rammer. Here you can see the some of the diagrams of a rammers. So usage of a rammers in Foundry. You can see here. So this rammer is a hard wood. So this hammer has flat end for pressing the sand. So it has two edges. That is one is butt end and second one is pin. So with the butt end, that is flat end, just we have to apply the pressure on the sand so that it can be rammed. Another end has a pin for pressing sand into the sides. Next one is a trowel. Next one is a trowel. So here we can see the trowels. See here we have three different types of trowels. If we observe the figures, these three figures, so we can able to know the difference between these three types of trowels. Right. So this trowel is used for smoothing and patching surface of the mold. Okay, so this is used for smoothing and patching surface of the mold, and this is used for cleaning the surface of the molding sand. The next one is slick. Here we can see the diagram of a slick. Here we can see. So slick has a flat surface on one end. If we observe in this figure, so it's able to know that so one end of the stick is have a flat surface and the other has spoon on the other end. Yes. It is used for patching and smoothing of the mold. It is used for patching and smoothing the mold. The next one is lifter. Next one is a lifter. Right. So next one is a lifter. This is a diagram of a lifter. Okay. So lifter has a small rectangular flat surface on one end. So here in this, if you observe this figure, so it will know. So this is a diagram of a lifter. On one end, a small rectangular flat surface is provided. Okay. So at the other end, next. So it is made of a mild steel. Next, lifter is used for repairing the mold sand and for removing sand particles. So whenever you are performing or whenever you are doing foundry or casting, so that time it is very very useful to remove the sand sand particles. Next one is bellows. So in this diagram you can see the diagram of a bellow. So it is used to blow excess parting sand in mold. Right. So this bellow is used to blow excess parting sand in mold. Next, it is made of leather bags fitted in wooden frame. So with the help of a leather built material, so these bellow bags are prepared and which is fitted into the wooden frame. That is called a bellows. Next one is the strike of bar. So this is a diagram of a strike of bar. Right. So the strike of bar is made of wood or metal with straight edges. So the strike of bar consists of a straight edge, so which is made of either metal or by wood. So mostly we are seeing this type of stack of bars. So which is made by the metal. Next, it is used for cutting extra sand. Okay. So this is used for cutting extra sand. Next one is the vent rod. Vent rod. A steel wire or good a steel wire or rod with sharp pointed edges. Okay. So steel wire or rod with sharp pointed edges is known as a vent rod. Next, this vent rod is used for making small holes in the sand for mold. To dissipate the hot gases from the molding sand, definitely we required a small holes. So those small holes are prepared by the vent rod. So molten metal. So molten metal is poured into the mold cavity. Next one is a screw pin. Next one is a screw pin. So a tapered wooden peg. A tapered shaped wooden peg used for cutting risers through, through which gases can escape. So next topic is a gate cutter. Gate cutter. So here we can see the some of the diagrams of a gate cutter. So all these components are very small. Okay, recognize all the components. Right. So next topic is a gate cutter. The gate cutter is made of sheet metal bent into U shape. Okay. So this cutter is made from the sheet metal work, so which do not have any which can have U-shaped. Next, it is used for cutting heat in the mold to flow the molten metal very easily and quickly. So definitely it requires a gatings. So with the help of this cutter, so we can make some gateways to flow the water in the. So next one is a swab. This is a soft brush used for moisturizing the sand around the batter. Next one is raw spikes. So it is used for lift pattern from mold. Raw spikes. These raw spikes are used to lift the pattern from the mold, which is taken between the two boxes. Next one is the wrapper. A fork sharp rod. So this wrapper drives the draw pins into pattern. Next, lifting plates. So here we can see the different types of lifting plates. So this lifting plate is made of iron. It is used to lift pattern from molding. Next one is a clamps. Next one is clamps. So here we can see clamps, different types of clamps. So here we can see the usage of clamps in Foundry. So clamps are used for locking the cap, rope and drag together. So by using a pin, so here we are locking the rope and drag together. Next one is a mallet. That is a Timson's mallet. Timson's mallet. So this is a mallet is a hammer, wooden hammer. It is used for holding pattern from mold by applying blows. So next one is a spirit level. But this is a diagram of a spirit level. So with the help of this, you can find the leveling of the component. So the next topic is spirit level. So it is used for aligning the flasks. And the next one is the water sprinkler. So this is very important in Foundry. Why? Because so without the water sprinkler, the molding sand would not be sticked or become wet. So it is used for sprinkling the water to wet the molding sand so that so we can use the molding sand in a proper manner to prepare the cavity. Next, molding sands. So here we can see different types of molding sands. So first of all, we would like to know about the molding sand. So this molding sand consists of sand with clay or binder. Okay, so it is used to make mold. Okay, so and this molding sand can be reused. This is the no, this is the about molding sand. The next properties of molding sands. What are the properties we have for the molding sand? First one is the porosity or permeability. Okay, the porosity, a porous material. So gap between sand particles provides passage for flow gases. So gap between the sand particles provides passage for flow gases. So the gases will passes through the small gaps from the sand particles. Next, plasticity. So acquires the shape of a pattern. So deforms to required shape. Next one is flowability. It flows into corners and deeper into molding box. The next one is the collapsibility. You can see here. So it can be broken into particles and can be reused the molding sand. Next is adhesiveness. So adheres to surface of pattern and molding box. So cohesiveness. Ability of sand particles to stick each other. The next one is last one is the refractoriness. So it can withstand the higher temperature. So it withstands heat of molten metal. So next topic is the types of molding sand. So here we have natural sand, synthetic sand, and special sand. So among them, first one is a natural sand. So here we can see how will be a natural sand. Okay, right. So sand collected from the river beds and pits. So from the river beds and the pits, the sand will be collected. So added with 5 to 20% of clay. So with this sand, so we are adding a clay of 5 to 20%. Next, clay develops strength and plasticity. So by adding the clay, so we can develop the strength and plasticity of the sand. Next, this natural sand can be used for non-ferrous metals, metal castings, and gray cast iron castings. Yeah. So next sand is a synthetic sand. So here we can see the synthetic sand. How we are using the synthetic sand. So it is a clay-free sand. Synthetic sand is a clay-free sand. So the meaning of clay-free sand is means nothing but so there is no clay in this sand. So it is a mixture of sand, bentonite 3 to 5% binder, and water 3 to 4%. So that is the mixture of sand and bentonite water, and it is used for ferrous castings. Okay, the synthetic sand is used for ferrous castings. So third one will be the last one will be the special type sand. So it is high refractory sand. Sand is a high refractory sand and it is used for accurate castings. Okay. Next, for examples, uh, zirconium, polyventonite, romanite, magnesite. So all these are the some of the examples for special sand. Okay. Next, advantages of synthetic sand over a natural sand. So here we can see the some of the advantages of synthetic sand over the natural sand. So more uniform grain size. So in synthetic sand, there is a more uniform grain size than the natural sand. So high permeability. So moldability, easier control of properties in the synthetic sand, suitable for variety of castings. Next, limitations of synthetic sand over a natural sand. You can see the limitations of synthetic sand against a natural sand. So first one will be the high initial cost. The cost of the synthetic sand will be high as compared to the natural sand. Next, patching is difficult. So with the help of synthetic sand, so it's very difficult to patch like so dries out fastly. Okay, so the synthetic sand will become drier in a quick time. Next, skilled labor is required for the synthetic sand. Next, next will be the classification of a molding sand. How we are classifying it? molding sands. So we can see here. So first one will be the green sand, second dry sand, third loam sand, fourth facing sand, fifth baking sand, and sixth one will be system sand. Seventh one is parting sand. The eighth one will be last one is core sand. So all these are the different types of molding sands. That is classification of molding sands. So here we have eight types of sands. Okay, so this is the classification of a molding sand: green sand, dry sand, loam sand, facing sand, baking sand, system sand, parting sand, and core sand. So now we'll see the green sand. So it is a, so we can see here. So foundry sand containing moisture. So this green sand containing a moisture. So green refers to the moisture content. So green refers to the moisture content. Yeah, silica sand is about 18 to 30% of clay plus 6 to 8% of water in green sand. So this sand can be reused. So it is used for small and medium casting products. Next one is a dry sand. So it is a moisture free sand. So it doesn't have any moisture content in this sand. Okay. So it is mixed with binder, that is bentonite and water. It is used for medium and heavy castings. So this dry sand is used for medium and heavy castings. So next third one is a loam sand. So it is a mixture of sand and 50% of clay. Next, it is used for large castings like pipes, rolls of paper mills. Next one is the facing sand. This is the fourth one, type of sand. So it is applied to surface of the pattern. So it is used for getting the smooth surface of the molding sand. So the layer thickness in molding in mold ranges from 20 to 30 mm. Okay, and the fifth one is a baking sand. So this baking sand is used to support facing sand. Okay, so to fill a rest of flask. So this baking sand is used to fill rest of flask. So this baking sand is porous moisture of sand. Okay, so next will be the system sand. So it is preferred. So it is prepared from used sand, already used sand. This system sand is prepared. So it is reconditioned. It is, system sand is used to fill complete flask. It possesses high strength, porosity, and refractoriness. So next one will be the parting sand. So this parting sand is a fine sand dust. So it prevents sticking to pattern surface. So it doesn't have any wet sand. Okay, so it prevents sticking to the pattern surface. So for example, the brick powder. So brick powder. Okay, so last one will be the core sand. Okay, it is used for making cores. Okay, this core sand is used for making cores. It consists of silica sand, binder, lined seed oil, rinse, and water. So it consists of silica sand, binder, and water. Okay, so it possesses high refractoriness. Okay, this core sand possesses high refractoriness. So next last one will be the ingredients in foundry sand or molding sand. What are the ingredients added in the molding sand? So sand contains either natural sand or a synthetic sand. Next will be the binder, clay, organic binder, bentonite, linseed oil, rinse. Next C will be inorganic binders, Portland cement, sodium chloride, silicate, and last will be the water. Okay. Next, so this is the last topic, I think so. So that is sand additives. So these are added to molding sand to control sand properties. So by adding these sand additives, so we can control the molding sand properties. Okay. So first is coal dust. So why it is used? So coal dust is used to improve the surface finish of the molding sand. Next is wood floor. Wood floor. So this is used to improve the collapsibility of core. Next third is silica floor. So reduce metal penetration. Next fourth, iron oxide. Increase dry strength. Okay, that will be the these are the different sand additives.